The topic is theoretical probability versus experimental probability. The essential question is, can you compare theoretical probability with experimental probability? So you'll see right here in the notes part, there are two columns. The first one, we're going to write down the definition of theoretical probability. So theoretical probability, this is calculated probability. Okay, and what that means is it's just the math problem, okay? You don't actually perform the experiment. It's just the math. And since you're not performing the experiment, it's just the math, everyone should always get the same answer. So here's an example, and we're going to go ahead and do the theoretical probability. And on all the assessments that we're going to be doing, it's all going to be theoretical probability. Everyone should get the same exact answer because you won't be actually performing the experiment. So the example says, if you flip a US quarter 8 times, how many times should you land on heads? So using theoretical probability, we're going to figure out that answer. So to represent this, we'd write the probability of landing on heads. And you should know, just with a US quarter, there's a head side and a tail side. And we're interested in landing on heads. So just to land on heads with just one flip, it'd be 1 out of 2, 1/2. But they're saying, hey, you're going to flip it 8 times. So what you would do is you'd go 1/2 and multiply that by 8, okay? So I got the 1/2 right there because that's the probability of landing on heads. But remember, we're going to flip it 8 times. Okay? So that's a probability of just flipping it once. And then doing it 8 times, you want to multiply it by 8. Another way you can do this is just going, okay, so the first time is 1 out of 2, so that's my first flip. Second flip, third flip, fourth flip, fifth flip, sixth, seventh, and eighth flips. So then the second time when I flip the coin, I'd have another 1 out of 2 chance. The third time I flip, I'd have another 1 out of 2 chance. Fourth time, another half a chance. That's a plus sign. Fifth time, sixth time, seventh time, eighth time. 1, 2, 3, 4, 5, 6, 7, 8. 1/2 plus 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 1/2 would give me 4 times. Okay? That's how many times we'd expect to land on heads if we flip that coin 4 times. So instead of we're doing repeated addition, we can just multiply. So that's where I got the 8 from the 8 flips from right there. And I'm going to just go ahead and multiply straight across. 1 times 8 is 8. 2 times 1 is 2. 8 divided by 2 is 4. 4 times. Okay? That answers our question. How many times should you land on heads? 4 times. Using theoretical probability, okay? Now, let's go ahead and move on to the definition of experimental probability. Now, this is probability where you collect the data in the experiments. You actually perform the actions. And people might have different answers based on their own data. So, our example, if you actually, in real life, flipped a US quarter 8 times, how many times did you really land on heads? Okay, using experimental probability, go ahead and find a quarter, and I want you to flip that 8 times and record how many times you landed on heads, okay? And you'll come to find out that you may not have the exact same answer as someone else in the class. So I put that box right there for you to record how many times you landed on heads, okay? So down here, you'll see, what you're going to notice is you'll see that the more times you do an event using experimental probability, the closer your experimental probability's answer will be to its theoretical probability's answer, okay? If that doesn't make any sense right now, we're going to revisit that statement in the pages to come. So according to theoretical probability, you know, when you don't act it out, when it's just the math, when you flip a US coin, how often should you land on heads? Well, you should land on it half the time, because the chance of landing on heads is 1 out of 2. And if you flipped a coin 10 times, you should, according to theoretical probability, land on heads 5 times. If you flipped a coin, a US coin, 100 times, you'd land on heads half the time, so 50 times. So that answers this question. According to theoretical probability, you'd land on heads half the time. Okay, so example, if you flipped it 8 times, like on the previous page, you should expect to land on heads 4 out of those 8 times. 4 out of 8 is half. Okay, so now let's see how this compares to its experimental probability. I want you to flip the coin according to its sample size and keep a tally of how many times you land on heads and tails. So this is something that you're going to have to do at home if you didn't come to class today, okay? So you're going to have a coin, and I told you all in class to bring a quarter, but really it doesn't matter. I just want a coin that's not a trick coin. I want a head side and a tail side, okay? So I want you to flip that coin, whatever you have, I want you to flip it 2 times. And when you flip it twice, I want you to tally the number of times you land on heads. So if you flip it twice, you land on heads twice, you put 2 tallies there, okay? And then within those 2 flips, if you didn't land on tails at all, just put a 0 there, okay? So I want you to keep track of the tally. So you're flipping it twice. If you land on heads the first time, put 1. And then if you land on tails the second time, put a 1 right there for tally, okay? And then I want you to flip it 10 times. Keep a tally of how many times you land on heads, how many times you land on tails. These 2 columns should add up to this, okay? Your tallies. So this column plus this column should add up to 10. When you flip it 50 times, this column plus this column should add up to 50. Okay, I want you to flip it 100 times, tally your results. Flip it 300 times and tally your results. Again, this plus this should equal this, okay? All right. And I want you to write down your experimental probability. How many times did you land on heads, okay? And write this as a fraction. So if you landed on heads, right here, if you landed on it 3 out of the 10 times, you'd put 3 over 10, 3/10, okay? Now this column right here I can totally do with you because we're all going to get the exact same answer because it's theoretical probability. So right here, remember theoretical probability is just the math. How many times are you supposed to land on heads? Well, the probability of landing on heads when you flip it twice. Here's how you'd write it out. So probability of landing on heads, that is 1 out of 2. And how many times are you flipping it? Twice. So that's why I'm going to multiply it by 2. Or you can add 1/2 twice if you want. But that might get a little messy once we get down further in these columns. Times it by 2 flips. This represents the flips. I'm going to turn it into its fractional form so I can just multiply straight across so it's easier for my brain. 1 times 2 is 2. 2 times 1 is 2. 2 divided by 2 is 1 time. Okay? That's how many times we should expect to land on heads if we flipped it 2 times, according to theoretical probability. Okay, for that next row, you're going to flip it 10 times. Again, we were interested just in heads. So if you just flipped it one time, your chance of landing on heads is 1 out of 2 because there's one head out of 2 sides. And this time we're going to do 10 flips. So I'm going to put it in its fractional form so I can easily multiply that in my brain. 1 times 10 is 10. 2 times 1 is 2. 10 divided by 2 is 5. I expect to land on it 5 times according to theoretical probability. Okay. Then the next row, we're going to flip it 50 times. So again, probability of landing on heads is just 1 out of 2, you know, 1/2. And we're flipping it 50 times. I'm going to label that flips, so when you're going to study, you'll know what that 50, where that 50 came from. Let me put it in its fractional form. 1 times 50 is 50. 2 times 1 is 2. 50 divided by 2 is 25. And it's 25 times. That's how many times we'd expect to land on heads if we flip that coin 50 times. Because you remember, we'd expect to land on it half the time according to theoretical probability. Okay, this one right here, flip it 100 times. So probability landing on heads, again, is also 1/2. But this time we're flipping it 100 times. And I'm going to multiply straight across. 1 times 100 is 100. 2 times 1 is 2. 50 divided by 2 is 100 divided by 2 is 50 times. Okay, this last one for theoretical probability, you're flipping it 300 times. How many times are you going to land on heads according to theoretical probability? Well, here's what you should expect. You land on probability of landing on heads is 1 out of 2. You're flipping it 300 times. So you should expect to land on it. Let's see. 1 times 300 is 300. 2 times 1 is 2. 300 divided by 2, that's 150 times. Okay, so that's all using theoretical probability. Now when you compare your experimental probability, you might find that it might be similar or it might be a little bit different. Right now I want you to examine the data you collected. What do you notice when you compare each sample size with your experimental and theoretical probability findings? So what this means is I want you to have a response right here that talks about the comparison between these two. So right here, when you only flipped it twice, how did this answer match up with this? Was it the same? Was it different? Okay. When you flipped it 10 times, did this answer match up with this? And then when you flipped it 50 times, are these pretty close, or did they match up at all, or were they way off? When you flipped it 100 times, were they pretty close, or were they way off? All right, the findings. When you flipped it 300 times, how close were you to each other? Okay. If you have any extra time on your hands, I do want you to try flipping it 500 times and seeing how, when you flip it experimentally 500 times, how that would compare with its theoretical probability answer. All right? Because something that you should hopefully find is this. You'll see that the more times you do an event using experimental probability, so the more times that you flip it, like down here, the more times you do that, the closer your experimental probability's answer will be to its theoretical probability's answer. So in other words, the more times you flip it, the more close the answer will be to its theoretical probability's answer, okay? Right? And then, in your own words, I want you to compare theoretical and experimental probability. So how are they alike? How are they different? Compare them, okay? For your summary, I want you to answer this question. If you spun the spinner 20 times, how many times would you expect to land on green? You're going to use theoretical probability, so you're not going to act it out, and you're going to assume each section is congruent to each other. So assume all the sections are equally the same size, okay? And I do want you to show your work. How many times would you expect to land on green? Also assume that you're not going to land in the middle, like on the black line, okay? All right.